Okay, last thing in this particular unit, last type of problem, and it is called a titration problem. But what it really is it's just using molarity as a conversion factor. So that's really all it is, just using molarity and conversion factor. So it's just different type of stoichiometry. So a thing called a titration, which we actually teach you guys next year. We actually do those in the acid base unit, which we do in senior year. A titration is when you have a chemical that you know the molarity of and you put it in a chemical that you don't know the molarity of, and you do some math to figure out what the molarity was of your mystery solution. So in our notes, it says a titration takes what we call a standard solution. And that standard solution is something that we know what it is. So like we can look up the molarity, it's on the bottle. And so this is a known molarity, meaning that I know it's 5 molar, or 2 molar, or 12 molar, or whatever. Okay. And so then we take that and we put that into a chemical that we don't know the molarity of, right? So we know the molarity of one and we don't know the molarity of the other. So it is unknown. So what happens is that you'll have this setup. And so we'll have a burette. You guys saw those in class. We actually didn't see them in class. We saw them on the video. So we talked about titrations on the video. And so then you have a burette like this, and what it does is it drops chemical drops at a time, and then what happens is you read in your burette how much we've used. So we're dropping these chemicals in here, and it goes into a container. And so in the container, we would have a chemical, and we would not know what the molarity is. So we would have this chemical, but we wouldn't know what the molarity is. And so what happens is we drop these drops in, drop, and we're looking for a color change. The color change is going to signify that we had a chemical change, and that basically the pH has shifted. And so when it changes to, let's say, pink, even though it's not pink, when it changes colors, then you would stop because you've hit what's called the equivalence point. But you don't need to know any of that. What you need to know is that if you see a problem like 27, that we're going to use molarity to help us solve it, because molarity is an excellent conversion factor. Now, this is a very long problem, has a lot of conversions, and so you give yourself a decent amount of space when you're writing this out. So first thing, looking at your problem, and it says how many milliliters. So we're looking for volume. We're given a molarity, another volume, and another molarity. Okay. Now, the trick in spotting these is looking for volume, molarity, or molarity, volume, and then also seeing that we have two different chemicals here. So two chemicals, that means stoichiometry. So this is a titration problem, is a stoichiometry using molarity. So that's it, stoichiometry using molarity. So first thing, we have to have a formula. So we're going to go silver nitrate. And the silver nitrate we know is with the sodium chromate. Oops. Okay. Now, this is called a double replacement reaction. So if you forgot those from last year, that means the fronts are going to switch places. So the silver and the sodium are going to switch places. You might want to note that this is a double replacement. So that's what this is, double replacement. So our new chemicals are going to be sodium. And now the sodium's hanging out with the nitrates. They switch partners, and I check my charges. This is a +1, this is a -1, so that's fine. And then the silver is with the chromate. Now the chromate, though, is a charge of 2, so it's going to look like this. This is a -2, and this is a +1. So when they crisscross, that's what you get. So I got to balance it up. Just go ahead and balance that real quick. Need a 2 here, and need a 2 here. Okay, so let's write down our chemicals. I'm going to write them down underneath because I don't have space up top. Normally I do it up top, but we've got 2 values for the sodium. So for the Na2CrO4, so the sodium chromate is going to get the 750 milliliters, and it's also going to have a molarity of 2.500 molarity. And we're trying to figure out about the silver nitrate, and the silver nitrate is 1.250 molarity, and we're trying to figure out how many liters of this stuff it takes to neutralize the other. So basically, how much of this does it take to neutralize that? We know the data here, and we know the strength here, but how much of this do I need? How much am I going to be required to use? And so that's basically what we're after. Now, this is just a stoichiometry problem, so just like all those things, we're going to go ahead and say, well, we're not going to use these chemicals today, so we're going to not get confused by them, so we're going to X them out. Okay, so always, and you want to write this down, you start on these problems, start with the chemical with 2 pieces of data, or you start with a chemical with 2 values. And so it's going to be, in this situation, you should have a volume, and you should also have a molarity. Okay, so whatever has a volume and a molarity, you start with that chemical. So I'm going to start with the Na2CrO4 because I have 2 values. Now I'm going to start with the volume, because if I can get the volume to liters, I can get liters to moles, and then off we go. So we're going to start there. And I'm going to use a lot of space here, so I'm going to kind of, start over in this corner. So 750 milliliters of the Na2CrO4. Okay, so first thing I'm going to do is convert that into liters. Okay, so right here, we're going to convert that into liters. So 1 liter is 1,000 milliliters. Okay, so let's do a good job with our units here. And we can see that right away I've got rid of milliliters. And so we are on the right track. Okay, so we got rid of the milliliters. Boom and boom. Okay, now this is where we're going to use molarity to help us out. Molarity can get us, because remember, molarity equals moles per liter. Well, look, we've got liters, and we'd like to have moles, so then we'll just use molarity. So this is how you do it. Put the liters on bottom, 1 liter, and the moles on top. Well, what was the molarity? It was 2.50 moles per liter. So see 2.500 moles per liter, because that's what that means. This M means moles per liter, right? So that's super useful to us. Okay, now it's stoichiometry, so we're going to go from chemical A to chemical B. All right, so chemical A to chemical B, going to need a little bit bigger line than that. So it looks like we're going to go to the question mark right here. 2 moles of AgNO3, and we're going to get rid of what we have. So we have this one, so we only got 1 of those. Let's get rid of it. 1 mole Na2CrO4. And I'm going to need a little more space. I'm going to have to clean that up a bit right there. Okay, so now I have moles, but see, we're supposed to go to milliliters. So I'm going to use the moles, and I'm going to again use molarity to go where I want. So molarity is moles per liter, and we know it's 1.25 moles per liter. And so if I want to get rid of the moles, 1.250 moles are on the bottom. And look, now you can go to liters, because what 1.250 capital M means is it means 1.25 moles per liter. So what I did is I just flipped it over and put the moles on the bottom. And here we put the moles on the top. And that was just because, did we want moles or did we want to get rid of moles? And so we wanted to get rid of the moles. And so that's why we did it this way. So this is the molarity as the conversion factor. Super, super, super important. So let's finish it up and convert into milliliters. Really easy. It takes 1,000 milliliters for every 1 liter. And then you have to check your units. Liters have canceled. Oh, I need the blue pen. Liters have canceled. Moles have canceled. Moles have canceled again. Our starting chemical is canceled. Liters have canceled. We have milliliters left and silver nitrate. Those are the things that we want. So now we can run it through and we can get an answer. Okay, so let's do that. 750 divided by 1,000. Hit enter. Times 2.500, hit enter, times 2, hit enter, divided by 1.250, and then times 1,000. And when you do all of that work, you're going to end up with an answer of 3,000 milliliters of the silver nitrate. And there's your answer. Right there. Okay. All right. Before we move on, so we've got our answer over here. 3,000 milliliters of the silver nitrate. That is only 1 sig fig, but we'll be okay for now. And I do want you to write out that this is molarity. This is molarity as a conversion factor. That's what we're doing here, is we're using molarity as a conversion, and then we'll just sneak factor right there in the bottom as a conversion factor. Didn't work out quite as well as I'd hoped. That's okay. But it's really important that you understand that that's really what's happening here. It's not that we're doing anything with these titrations. We're just using the molarity to help us get to moles or help us get to liters. All right, so this is why we're doing it right there. Okay. All right, I'm going to pause it here. We'll pick up with the next one.